All right, so we've gotten into polynomial division, and we can now divide a polynomial by another polynomial, find out if it's a neat and clean factor or if it is just divides in and leaves a remainder. But we haven't gone into why this is significant, and we also haven't gone into a shortcut to make this a little bit quicker called synthetic division. So that's what we're going to do here. First of all, why is this significant? Well, let's take a look at a function and we can illustrate why. F of x is equal to 2x squared plus 7x minus 15. Now, in a few days, you're going to learn about something called the rational zeros theorem that's going to give you an idea of where all the zeros could be. But since we haven't done that, I'm going to fall back on the calculator. We pay good money for this thing, so let's put it to work. 2x squared plus 7x minus 15. We graph this up and we get a parabola that is facing up like we would expect. And when we're looking at the zeros of that, right around here it looks like it might be about 1.5, might be 1 1/3. It's kind of hard to eyeball. These TIs don't have really great resolution. Right here, it looks like there might be a 0 at x is equal to -5. But again, I can't tell exactly just by looking at that graph. But if this is a polynomial, and x equals -5 is a 0, then this tells us something very, very helpful for simplifying this out, and that is that x plus 5 must be a factor. So if we were to try and divide x plus 5 into that function here, then what we should expect is that it would go in without a remainder if x equals -5 truly is a 0. Well, let's try it out. X plus 5 going into 2x squared plus 7x minus 15. X goes into 2x squared 2x times. 2x times x plus 5, we get 2x squared plus 10x. Subtract 2x squared, we get 0. Subtract 10x from 7x, we get -3x minus 15. I'm running out of room here. I'm going to extend the page a bit. All right, x goes into -3x minus 3 times. -3 times x is -3x. -3 times 5 is minus 15. And it divides cleanly. So our function, which was above written as 2x squared plus 7x minus 15, could also be written as x plus 5 times 2x minus 3. And this tells us that we have zeros at x is equal to -5. And if we solve that 2x minus 3 for 0, or set it equal to 0 and solve that for x, what we're going to get is 3 halves. 3 halves, of course, is 1.5. So when we take another look at our graph, there's our -5, there's our 3 halves. So it actually did look like 1.5, and it turned out to be that way as well. So that is why we're getting into this polynomial division, is because it actually aids us in finding the zeros. Well, the problem with this polynomial division is that it takes a while, and it would be really nice if we had a quicker and easier way of doing this, perhaps one that didn't involve so many steps and therefore wasn't so error prone. And in order to do that, we do have a shortcut. It's called synthetic division. It's called synthetic division because it is a tool that we have made in order to make the division work better, hence the term synthetic. It is a shorthand way of dividing a linear factor, and we'll get into that in just a moment, into a polynomial. And when I say a linear factor, what I mean is x plus or minus some number. Okay? We're not going to be able to divide a quadratic into a higher order polynomial. It's got to be a linear factor. And here's how this would work. If we wind up using, I'll use the example that we used yesterday. We've got x squared plus 8x plus 15 divided by x plus 5. Okay, now, this is an example we did yesterday. We know that if we factor x squared plus 8x plus 15, we're going to get x plus 5 times x plus 3. So we would expect that when we divide these two, we're going to get x plus 3. And lo and behold, when we did it by long division, that's exactly what we got. Well, let's try this by synthetic division. Here's how synthetic division works. First, we draw this shape here. It looks a lot like a regular division sign, but it's been flipped over. And we need to leave some room right here and right here for actually two rows of numbers. First, in the top row, I'm going to put the coefficients of my numerator, the polynomial that I'm dividing by. So I'm going to ditch all the x's, and I'm going to have 1, which is the coefficient from my x squared term. I'm going to have 8, which is the coefficient from my x term. And I'm going to have 15, which is my constant term. So we can see that this dropped right down like that. So 1, 8, and 15. Now, with this x plus 5, this is very, very important. What we need to look at is we need to look at if that were a factor of this polynomial, the 0 that it would give us would not be at 5, it would be at negative 5. And so the number that we wind up putting out here is not 5, it's negative 5. So we wind up switching the sign. Okay, this is a very important little subtlety there. If you don't switch that sign, of course, you're going to wind up getting your wrong answers. These numbers here are your coefficients of your numerator. Okay. In order to divide these, there is a very short little bit of steps that we wind up repeating over and over again. First thing we do is this first coefficient, we simply take it down. So we have a 1 right there. Next step is we're going to take this negative 5 and we're going to multiply by that 1 and we're going to put it right here. Negative 5 times 1 is negative 5. Then we're going to take this 8 and this negative 5 and we're going to add them together. So 8 plus negative 5 is 3. Once we've done that, we do the exact same multiplication step again. So those short little steps there are the only thing that we are doing that's new after that. We are repeating and repeating and repeating. So negative 5 times the 3. Multiply them and put that right here. Negative 5 times 3, we get negative 15. Just like we added the 8 and the negative 5, now we're going to add the 15 and the negative 15, and we're going to get 0. Now, the numbers that we have down in the bottom here, they may look familiar, the 1 and the 3 and the 0. Here's their significance. I'm going to scoot up a little bit here. This 0 right here, this last number in our bottom row is our remainder. These numbers right here are our new coefficients. This coefficient up here with the 1 right here, its power was x squared. So we're going to lose one of those powers, and we're going to get 1 times x. And we're going to have positive 3 times as its constant term. So where we had a cascade of terms here, x squared, x, and then our constant term, we're going to do the exact same thing down here where we have an x and a constant term. We just started with 1 power lower. So the result is x plus 3. We can try it again without all the arrows. There we are. 2x cubed plus x squared minus 4x minus 3 divided by x minus 1. So we do the exact same thing. We set up our sign. X minus 1, since the 0 that would give us is positive 1, we'll put a positive 1 out here. And then we're going to put our coefficients of our numerator, the numerator right here, we're going to put those coefficients up here. So we're going to have a 2, a 1, a -4, and a -3. Now we do the exact same steps as we did before. We carry down the original 2. 1 times 2 is 2. Add these two together. 1 plus 2 is 3. Multiply the 1 times the 3, and we write it up here. Add these two together. -4 plus 3 is -1. Multiply the 1 by the -1, we get -1. Add the -3 and the -1, and we get -4. We set up our powers the same way we did before. This is our remainder. I'll use a big capital R for that. This is our constant term. This is our x term. This is our x squared term. So when we write our answer down, we have 2x squared plus 3x minus 1 minus our remainder, which is 4, and our remainder is still being divided by x minus 1. So again, this coefficient for the 2, or that coefficient 2 was for an x cubed. You lose 1 power, and now it is for an x squared. This coefficient 1 was for an x squared. You lose a power, and it's now for an x. And so you wind up with 4 terms up at the top, which are all coefficients, 4 terms down at the bottom, 3 of which are coefficients, and the last one is a remainder. Now we run into the same quandary that we had in long division, which is what do we do if we have missing terms? And the answer is we do the exact same thing. We sub in a 0 for that missing term. For example, if you have 2x cubed minus x plus 3 divided by x minus 1. As you can see in the numerator, there's an x cubed term, there's an x term, there's no x squared term. So the way that we rewrite this is as such. 2x cubed, that's unchanged, plus 0 times x squared, and then continuing on, minus x plus 3 divided by x minus 1. Now we are all set up for synthetic division. Draw our sign, divide by x minus 1, so we're going to have a positive 1 out here. We put our coefficients for our numerator, 2, 0, negative 1, and 3. And we proceed. 2 carries down. 1 times 2 is 2. Add 0 and 2, we get 2. 1 times 2 is 2. Add negative 1 and 2, we get 1. 1 times 1 is 1. Add 3 and 1, we get 4. So what we are left with is, since this is our remainder, this is our constant term, this is our x term, this is our x squared term. What we are left with is, once we do that division, is 2x squared plus 2x plus 1 plus 4 divided by x minus 1. Because that 4 is our remainder, it's still being divided by x minus 1. Now that we've done this, please go into this section in your book in which we are going into synthetic division, which is 4.3. And for practice, try number 31, 32, and 33. Just 3 problems, and have a good evening.